All right, we're back at it. For today, we're going to try and troubleshoot the filter section, right? This is the front board of the Microbrute. Last time, we already did a little bit of cleaning up top, just brushing away all the dirt and the gunk that's built up around the knobs and around the sliding potentiometers, right? And some of the dirt that was on top of these switches, right? Hopefully, just like what happened to the intermittent keys, we were able to fix it, right? Just by cleaning. I'm hoping with a little bit of cleaning on these knobs, switches, and sliding potentiometers, I hope we get it to work as intended, right? After much research, I've definitely decided on the DeoxIT route, right? I have used the DeoxIT F series, the fader series, to maintain some of our equipment. It's my first time using the D series, which is meant more for metal to metal connections, where the F series is meant more for metal and carbon connections, right? This one helps conductivity, and this one just cleans out any oxidation on your metal contacts, right? So we will definitely be using the D series on the switches. Switches are metal to metal contacts, that's for sure. We will most probably use it to clean initially, right? To clean up these rotary potentiometers and the sliding potentiometers. And after that clears up, we'll go ahead and proceed to lubricate all the faders and rotary knobs with the fader series, the F series, right? The ones I got are all 100% concentrates, just the 2 ml package, right? So maybe a drop or two of the D series and work the sliders and work the knobs. That should be enough to clean them. And then we're going to do 1 or 2 drops of the fader series, work the knob and the faders, and hopefully that's more than enough, right? To recondition these knobs and faders, and hopefully it works, right? And I actually like the design of these knobs. If you try and look closely, you can see that we have access to the rotating disc inside the potentiometer. I'm going to try and twist it. There, hopefully you guys see that. Right, so we definitely have access to the rotating disc inside the potentiometer. So a few drops of the cleaning D series will help clear out any gunk there. And then a few drops of the F series should help create good contact between the carbon and the metal contacts in there for the rotary potentiometers, right? For the sliding potentiometers here, I tried to peek in. It's quite hard to get light in there and for my camera to actually see. But I'm looking at what it looks like to be metal contacts in there. It's really hard to get the camera to focus in there, right? But I'll also be using the D series to clean it up and flush it out first. And then once that's dried up, I'm going to lubricate it with the F series, okay? So hopefully cleaning is all we need to do, right? But just in case, and since we're in here already, we are going to be checking some of the discrete components and then just, using a tester, check some of the discrete components if any of the components are not as they should be, right? And you guys can definitely refer to the schematic diagram. Here's the filter section, right? Your Steiner-Parker filter. The easiest section to troubleshoot is the three-way switch, basically. Fortunately, we have test points around the three-way switch for this multi-mode filter. We'll check for continuity there, and that's going to be an easy fix if the switch is malfunctioning, then it's just going to be what looks like a through hole component, and that can easily be replaced, right? Otherwise, the rest of the components here, which I'll show you in a while, a lot of them are surface mount devices and components, right? And that's definitely beyond my skill level. Anyhow, we remember that in low pass filter mode, we were getting signal over at the audio output. So that means parts of this filter circuit is indeed working, right? Your operational amplifiers here are working to a certain extent, of course. 'Cause we won't really know because when we set it in band pass and high pass, we weren't getting the right audio output here. But suffice to say, in low pass filter mode, the resonance knob was working. It was responding correctly. And the low pass filter was also responding to the cutoff frequency that we set manually. I remember when we assigned the mod wheel to control the filter cutoff frequency, that was also the right behavior. I remember we set the LFO to modulate the filter cutoff frequency. That was also behaving as expected. And after reading much more about the Steiner-Parker filter, pushing the filter and the resonance allows this filter circuit to self-oscillate. So apparently that was a normal behavior. That just means that parts of this NPN transistor, it's a bipolar junction transistor. It's a digital switch basically that accepts all of these modulation sources and then injects it back into the filter circuit, right? But yeah, some of the components that I'm eyeing are definitely these capacitors, these filters, the ones that are on the band pass filter circuit, the one that is on the high pass filter circuit, some of these capacitors, and then of course your diode, right? Your ladder diode here, which is the initially what characterizes your Steiner-Parker filter sound and design, which is this ladder diode, right? So excited to, or not really excited, but hopefully it goes smoothly, and let's see if we can get this filter back up and running. So we're going to start with metal connections. I'll be using compressed air first to blow out some of these dirt inside these potentiometers. So I'm just using WD-40 air duster. I've lost the nozzle on this, so we're going to do our best. All right, so we're going to proceed with the DeoxIT D series. Okay, that's all the switches. We're going to move on to the sliding potentiometers. All right, so that's it for the faders. I'm going to be dropping the DeoxIT D series on all these rotary potentiometers. I'm going to work them just to clean them up, and then we're going to leave it out maybe a few hours, 2-3 hours, just to dry up. Okay. Hopefully that feels better when we place the fader series. I can feel a little bit of grittiness happening there. I am going to do a quick wipe of that. Do we use isopropyl alcohol? Guess we should. Same one from last time. Alright, so we're gonna drop in some DeoxIT fader on that. And then we're just going to use the nozzle to deal with the rest of the pots. Alright, that's it. So he cleaned all the pots, reconditioned all of them, even though most of them were working correctly. But hopefully, for example, for the sound sources, I remember some of the pots here. It was a bit noisy once we reached the end of the turn. So hopefully, we'll see if that smoothens that out. But I'm more interested if cleaning the switch here, the 3-pole switch on the multi-mode filter, hopefully that cleans up that connection. I definitely should have checked the switch first before I cleaned it up, but anyway. So we're looking for test point 15, test point 16, and test point 18. We're also looking for test point 17, which is there. So we're on position C. Should be test point 17 and 18. Alright, we are. Let's move to position B. Position B should be test point 16 and 17. It's working. And of course, test point 18 is open. And 16 and 17 has continuity. So that was bandpass. Position B is bandpass, and right now we have connection. We should try test point A now, which is high pass. So we know that high pass position does not work. Position A, we should have test point 17 and 15. And true enough, we do have continuity on there. Yep. 16 and 18 are open. Alright. The switch looks to be in working order. I then proceed to check some of the discrete components that I do know how to check. Mostly capacitors, resistors, and diodes. For some of the capacitors, they are not actually populated, like C21, C20, and C16. But otherwise, I'm just using the diode test and checking whether the capacitors are open or shorted, and visually checking if any of the capacitors are bulging, right? And checking if they are indeed charging and discharging. So I'm not removing any of these caps from the PCB, just a passive check. I also check the resistors, and I just take note of which resistor was exhibiting values that are way beyond the 10% tolerance, right? As we all know, checking resistors in circuit sometimes leads to incorrect values because of the way the resistors are, depending on whether which components are in series or in parallel to the resistors. But yeah, so I just took note of those resistors. And finally, the diodes. For this particular silicon diode, you should be seeing a voltage drop of around 0.5 or 0.7 across the diode in forward bias. And when you swap your probes, you should see an over limit or an open circuit, and that indicates a good diode. I think that's about all the components that I can check, or at least that's the limit of my troubleshooting skills. So at this point, we are going to be rebuilding this back up, and we're going to see if we've affected the filter in some way, shape, or form.